Learning objectives.
At the end of this topic, you will be able to understand how to calculate mode and mode for the grouped data, evaluate problems based on mode and mode for the grouped data.
Introduction.
In Class 9, we have studied classification of the given data into ungrouped as well as grouped frequency distributions, representation of the data pictorially in the form of various graphs such as bar graphs, histograms, and frequency polygons, numerical representatives of the ungrouped data, also called measures of central tendency, namely mean, median, and mode. Mean of group data. If x1, x2, and so on up to xn observations with respective frequencies f1, f2, and so on up to fn, then x1 occurs f1 times, x2 occurs f2 times, and so on. Now, the sum of the values of all the observations. So, the mean x of the data is given by, in short form it can be written as, the marks obtained by 30 students in a science paper consisting of 100 marks are presented in the table below. Find the mean of the marks obtained by the students. Let's convert the ungrouped data of previous example into grouped data by forming class intervals of width, say 15. We know that while allocating frequencies to each class interval, students falling in any upper class limit would be considered in the next class. Example, 4 students who obtained 40 marks would be considered in the class interval 40 to 55 and not in 25 to 40. With this convention in our mind, let's form a grouped frequency distribution table. Now for each class interval, we require a point which would serve as the representative of the whole class. It is assumed that the frequency of each class interval is centered around its midpoint. So the midpoint or class mark of each class can be chosen to represent the observations falling in the class. With reference to the table, for the class 10 to 25, the class mark is 10 plus 25 divided by 2, that is 17.5. Similarly, we can find the class marks of the remaining class intervals. We put them in Table 2 as shown. The sum of the values in the last column gives us summation of fi xi. So, the mean x of the given data is given by. This new method of finding the mean is known as the direct method. As we have calculated mean of group data using 2 methods, now question arises, which method is more accurate? The difference in the 2 values is because of the midpoint assumption in Table 2 and 59.3 being the exact mean, while 62 is an approximate mean. Sometimes, when the numerical values of xi and fi are large, finding the product of xi and fi becomes tedious and time-consuming. So for such situations, let's try a method of reducing these calculations. Now let us find the relation. Substituting the values of A, summation of fi di, and summation of fi from Table 3, we get, therefore, the mean of the marks obtained by the students is 62. The method discussed above is called the assumed mean method. From the Table 2, by finding the mean by taking each of xi, that is, 17.5, 32.5, and so on. As A, we will find that the mean determined in each case is the same, that is 62. In Table 3, the values in column 4 are all multiples of 15. So if we divide the values in the entire column 4 by 15, we would get smaller numbers to multiply with Fi. Here, 15 is the class size of each class interval, where A is the assumed mean and H is the class size. Now we calculate Ui in this way and continue as before. That is, find Fi Ui, An, D, then summation Fi Ui. Taking H is equal to 1, 5, let us form table form. Again, let's find the relation. Now substituting the values of A, H, summation of Fi Ui and summation of Fi from table 4, we get. So the mean mark obtained by a student is 62. The method discussed is called the step deviation method. Let's move to an example. The table below gives the percentage distribution of female teachers in the primary schools of rural areas of various states and Union Territories UT of India. Find the mean percentage of female teachers by all the three methods discussed in this section. Remark: the result obtained by all the methods is the same. So the choice of method to be used depends on the numerical values of xi and fi. If xi and fi are sufficiently small, then the direct method is an appropriate choice. If xi and fi are numerically large numbers, then we can go for the assumed mean method or step deviation. If the class sizes are unequal and xi are large numerically, we can still apply the step deviation by taking n to be a suitable divisor of all the di-s. Let's move to another example. The distribution shows the number of wickets taken by bowlers in one-day cricket matches. Find the mean number of wickets by choosing a suitable method. What does the mean signify? Let's have a recall about mode from the previous classes. We have learned that A mode is that value among the observations which occurs most often. Mode is the value of the observation having the maximum frequency. We shall discuss ways of obtaining a mode of the group data. It is possible that more than one value may have the same maximum frequency. In such situations, the data is said to be multimodal. Though group data can also be multimodal, we shall restrict ourselves to problems having a single mode only. Let us first recall how we found the mode for ungrouped data through the following example. The wickets taken by a bowler in 10 cricket matches are as follows. Find the mode of the data. In a grouped frequency distribution, it is not possible to determine the mode by looking at the frequencies. Here we can only locate a class with a maximum frequency called the modal class. The mode is a value inside the modal class and is given by the formula as shown. Let's consider the following examples to illustrate the use of this formula. A survey conducted on 20 households in a locality by a group of students resulted in the following frequency table for the number of family members in a household. Find the mode of the data. Let us consider another example. The marks distribution of 30 students in a mathematics examination are given in the table 2 of example 1 in mean of group data. Find the mode of this data. Also compare and interpret the mode and the mean. Summary. Let's summarize this topic. The mean for group data can be found by 1. The direct method. 2. The assumed mean method. 3. The step deviation method with the assumption that the frequency of a class is centered at its midpoint called its class mark. The mode for group data can be found by using the formula.